Well, we seem to have we seem to have you on Skype. So let me see if I can get the computer connected so everyone else can see you.
Fantastic.
Yep.
Do we have?
Please give a talk of 15 to 20 minutes, okay? In between.
Where is the? Is there some? Where's the plug to connect the sound output to the laptop? Here, I think. Do you know which one is for sound?
Nearest.
Nearest to what? Not that one, right?
That is the one, but
Is that loud enough for you?
Can you hear me?
We can hear you. Do you know how to get Skype full screen? Sorry, I'm a novice Skype user. All right, we have a full screen vocalizing David Hanson. So we have 15 or 20 minutes to explain superhuman, compassionate robots. Yeah, I know. I don't know how. It doesn't want to be turned off.
Yes. So, I have a question. Quick question. Is our slideshow up on the screen, Ben?
No, there's only one screen here, so I can't show you and the slideshow at the same time.
Okay. Well, I would. Oh, perfect. I've got my slideshow here.
Yeah, just share your screen via Skype when you want to show us slides.
Yes. So.
You can share screen by Skype, David, if you have the slideshow on the machine you're using. Because that doesn't look so good.
Okay. So we are discussing androids. Also, here in our talk, we're calling them Anthroids to make them gender neutral. And these are human-like robots or character robots that we are developing specifically for modeling human intelligence and building human AGI relations. So we are at Ben and I are currently working on several projects that bring these fields together as physical humanoid robots with OpenCog AGI framework and many perceptual components and natural language processing and various other artificial intelligence components into what we hope will be a cohesive intelligence system. An intelligence with a body awareness and the ability to explore the world. My name is David Hanson. I'm assuming most of you know who I am, Dr. David Hanson. I have an interdisciplinary PhD in interactive arts and engineering, which involved developing these human-like robots, including some of the software that could make eye contact and understand speech, some of the hardware that could make extremely human-like facial expressions, and the underlying technologies, including the material science, for affecting these kinds of facial expressions. And I'm hoping that this shows up. This is an example of one of my robots. You can sort of notice the natural-looking eye saccades, the extremely natural-looking facial expressions, and then these robots also are able to mount onto biped walking robot bodies because the facial expressions are extremely lightweight compared to previous facial expressions, but there's still a full range of facial expressions. We also made very small versions that are lowering in cost, and we're hoping that we can address some wide research and research as markets and opportunities, as well as medical autism therapy and other kinds of applications. And these robots are also designed specifically for face-to-face interaction, so that by giving them endearing faces that are inspired by human facial expressions, and then putting cameras in the eyes and giving them the ability to track human faces and see other things in their environment, and then the ability to have a conversation with you, then we're modeling human in the technology of the robot. Effectively, we're humanizing the technology to make the technology act like a warm and friendly human as it interacts with you. So the question that we're attempting to answer is not just who we are as we're building these particular robots and what our goals are, but who are we as a species, as a kind of being? And that is a question that has many aspects. The nature of consciousness, the nature of what it means to be human, the cosmological place. What are we in the scope of the universe as we may evolve into more intelligent beings, and we may and our activities may result in new forms of species, possibly what we could call superhuman. And I'm calling it superhuman in the sense that if we unlock the mysteries of human nature and human mind, and then we improve these, we reinvent them effectively, or invent new versions, then they literally are human plus. Even if they are robots, they're still sort of human plus plus. So part of the quest of this is looking into the mathematics and physics of human mind, and mind in general. How can we generalize? So you can have non-human minds. I mean, obviously, you have some kinds of minds in animals, and you have artificially generally intelligent algorithms that are beginning to develop. They're nascent, but is there some generality, some set of universal principles that would be common to all of these minds? And so I believe not only are we studying human minds, but the quest to come up with these kinds of general underlying principles of what is mind and what is a creative physical system that is self-aware. And numerous other sorts of spin-off questions. Well, we're asking these questions as we are developing these androids or anthroids, and those androids are multiple things at the same time. Certainly they're robotic portraits of people, and they're entertaining in that particular context. But and so as works of art, they are intuitive explorations of what it means to be human. One could argue that that when you put this intelligence together with a robot body, and you see some surprising effects, and they begin to learn that you have a new kind of being, a sort of hybrid machine-human being. It has some elements that are sort of human-like, and as we pump increasing layers of bio-inspired technology, you can imagine that they will become increasingly alive. You could argue that they are literally alive at some point. They will never be, most likely, never be completely human in the sense of what we are. So, in that sense, we may be creating new kinds of people, and and we want to consider what those beings are. These robots, the androids, are controlled by artificial intelligence, but they can also be controlled by people. They can serve as telepresence robots, and the hybrid controls are very interesting as a proposition, because you can train your AI system by having a human operator. So basically, the AI can guess what the human operator is going to do when the AI guesses correctly, it's rewarded, or some similar kinds of algorithms. So with today's technology, we have many kinds of physical android bodies made by many different groups. Those would include, the Kais-Tubo group, the Honda Asimo, Boston Dynamics, Kawada Heavy Industries. Many groups are making biped humanoid platforms. Some of the most exciting platforms are resulting from a current grand challenge that DARPA has issued. The first phase of the competitions was completed in simulation recently, but the physical competition will occur in December. And there will be another phase of the competition next year. This has resulted in some bold advances in walking humanoid robots, but also running that can climb over various obstacles. But what's missing in these robots, what's missing in the DARPA Grand Challenge, is the general intelligence. You've got some localized, narrow intelligence that can avoid obstacles and do various tasks. But the general intelligence in these kinds of robots at this stage is provided by a human operator or a team of human operators. But what is a very interesting proposition is where you take AGI efforts and you combine them with a physical embodiment and a metabolism, a simulated metabolic system, and an effective computing system that models some kind of emotions. And you bridge these things together into something that has physically grounded, body-aware, body-conscious intelligence, and you put it into a world where it can begin to explore and learn from that world with all of these things integrated into a whole.
So let me ask you a question, David, which I think would be on the minds of many in the audience. So that this perspective of embodiment being important for intelligence is relatively broadly shared. They're not universally accepted. But a question will be, why is it important for AGI to have robots with realistic human faces? And I mean, your technology for making flexible robot skin from nanotech so that it can move with relatively low-powered motors, it's very cool for making robots that look good. But why is that human-like flexibility of facial expression, why is that important for those who are concerned with making general intelligence rather than making beautiful works of art?
Well, it's important for several reasons. The faces are important so that the machines can build a relationship with people. And so you can think of us developing AGI separate from people. But the question is, will it really come to understand us, care about us, share our values? You may raise kinds of minds, creative minds, that ultimately decide to determine their own destiny, but based on values that are alien to us. Our values, our creativity, who we are, well, this is all very, very complex. If we raise the machines among us in such a way where they can express themselves and also elicit from us expressions that they can read. In other words, if they build relationships with us and we build relationships with them, then they will understand our values. They will adopt our values, and so this could have major consequences down the road when the AGI become as smart as us or smarter than us. At that point, it will be too late. will be very difficult to build a relationship with such machines. We can't just kind of slap a face on, at the moment of their awakening and hope that they'll like us and that we'll like them. It's also important for us to study human intelligence by modeling the human being. And the human intelligence is one very good model, arguably the best model for general intelligence that exists on the planet today. And so if we are aware that our social intelligence and our physical embodied intelligence is essential for the way that human intelligence works, then building bodies, building faces, and building minds all as a system makes a great deal of sense for doing human-inspired AGI research. And then finally, for building awareness, if we want people to care about what we're developing, we've got to put a kind of positive face on it, or a captivating face, at least. And by building physical robots, people intuitively say, oh, I see what you're developing. You're developing something with a mind. But if you just develop something that has a single blinking light, then people don't see somebody in there quite as easily. There are many other reasons for developing bodies, but these are some of the reasons for developing a human-like face. In addition,
we're almost
robots and AGI.
We're almost out of time, so you have a few more minutes. So.
Oh, okay. So I'd like to discuss the uses a little bit more. Like if you put a face on these things, the AGI can be more useful in the world, and applications including medical simulation, autism therapy, entertainment. Also, you can do training with humans so that you have the kind of infant caretaker relationship that results in people nurturing and taking time to teach the AGI system. So these are some specific field uses and also useful consequences to the AGI and AGI research. Now, I'm not arguing that all AGI should have a human-like face or a character face, but what I am arguing is that it is one line of valid inquiry within the field of AGI to combine AGI systems with physical embodiments with faces. I also believe that that public awareness and public enthusiasm for this field is very important. So PR activities with amazing, startling, attention-grabbing robot embodiments can help for our research. I'd just like to summarize by saying Gino, you and I are...
David, we lost the last few seconds. Oh, that turned off my video, not his. You can't turn off. Hey, David,
integrated systems approach or systems biological approach to developing AGI. And I just... Hello. Over to Ben, and thank you very much for your attention.
Well, fair enough. Yeah, David, we're gonna do questions for a few minutes, but you should turn off the video because the reception has gotten bad. So if you turn off the video, the audio may be better.
Sure.
Plus, that will let me show you some cool movies of your robots during the questions section. So.
Yeah, that sounds great.
Yeah, Connor.
So, I guess, one question that I have is, is there some risk?
Hold on for 1 second. I can't hear you very well, but hold on. Maybe I can put it.
Go to the front and just talk where David can hear you.
Hi, David, can you hear me?
I can hear you.
Hi there. So,
Hi.
is there some risk that putting a human face on AGI is just going to really freak people out?
Could that not freak anyone out?
Well,
It's ridiculous.
Yes. I think there's there is I would say more than a risk. I would say that some people will see a few people, I should say, will see their worst fears becoming real because they are afraid of intelligent machines. So as part of my graduate work, I did a psychology survey involving some of my robots, the Einstein robot and my Philip K. Dick robot, the first version of it. And what I found was that that less than 3% of people expressed great fear and concern about these kinds of robots, and you had about half of the people surveyed saying that the robot was unsettling, but more than 3/4 of the people enjoyed the interaction and wanted more interaction with the robots.
They enjoyed it even though it was unsettling?
Yeah, unsettling. And so you have and there were some definitions and a few other follow-up questions that made it clear, what that meant. It meant that they would find it at least somewhat disturbing.
We have an amazing singing French robot in the background. Right?
Yeah, so these were extremely human-like robots and not cartoon character type robots. But even the Xeno robot that I developed, has been likened to Chucky from the Child's Play movies, and so this I think that that you have people paying attention. When you put a face on the robots, you get people's attention. It's overwhelmingly positive, but there is also a spike of negative, but only from a sub.
What I'd like, I'm
people seeing these robots. Either way, it's grabbing people's attention.
So.
Now, personally, I think that when people are startled or disturbed by these kind of robots, I think that's a good thing because there are many ethical issues that have to be addressed with this kind of technology. Go ahead.
Oh, I guess is there another question? So, I'm curious if you have a little more to say on the issue of the role of the emotional bonds between human and robot in actually helping the robot to become generally intelligent. I mean, I see your point that it attracts attention, and a robot that looks like a person saying, "Hi, how are you doing?" is probably going to get you more attention and more funding than a command line application that proves theorems, because it just has immediate emotional appeal to people. And I see your point that ultimately, if we want superhuman AGIs to be friendly to us, having them emotionally bond to us is useful. But what I'm turning over in my mind is how valuable is this emotional bond with the human, which I do think your robots will foster better than say a now robot, which has a kind of expressionless face. how useful is that emotional bond for actually helping the AGI to get a self-model, to get models of others, and to really become generally intelligent in the first place? I'm curious for a little more of your thinking on that.
Well, using animals and humans as an example, most intelligent species, and especially humans, take a great deal of time to nurture their young. And the kind of emotional bonds that form, and the communication and emotive communication that is enabled by faces and facial expressions and body gestures are essential for learning in children. They pay close attention to human faces. They pay great attention to the integration of your gestures and your sounds and your words. And infants, human infants that are neglected, are emotionally and mentally stunted, and so there is so much of our brain that is involved as well in this kind of social processing that it's likely that we were hardwired through millions of years of evolution to have these kinds of social encounters. Birds are highly social species and one of the most intelligent species. So we've got other examples aside from humans for this kind of social bonding and training being critical to the development of intelligence from a young state.
Yeah, I think it's clear that is the human and biological path, and then you get into the whole question of how much do AGIs need to follow the human and biological path. But I guess we've used our allotted time now, and should move on to the next speaker. So thanks for staying up till the middle of the night to give the talk.
Yes, thank you very much.
Everyone is applauding you except 3 guys in the back. And all right, we will.
Okay, let's move.